Hi, welcome to this video. In this video, we discuss about we are going to compare the Carnot and Rankin cycles, as well as we are going to discuss about the effect of pressure and temperature on Rankine performance description, as well as in the TS diagram. These two topics comes under vapor power cycle, which is the module 3 of applied thermodynamics system. Before going enter into the detailed analysis about the comparison, first let us watch a simple video which give you the clarity between how and what is a Rankine cycle and Carnot cycle and what is the difference among these two, and that will give more clarity when we go and compare it further. First let us watch the video and come back.
The Carnot cycle is the most efficient heat engine, and the Rankine cycle is what powered the steam engines of the past and the thermal power plants of the present. This makes us wonder, what are Carnot and Rankine cycles? Before we jump in, check out the previous part of this series to learn about what steam tables are. Now, a Carnot cycle is an ideal hypothetical cycle in which all the processes are reversible. The cycle consists of 4 processes, 2 reversible isotherms and 2 reversible adiabatics. First, a reversible constant temperature process called as an isotherm, in which heat enters increases the internal energy of the system. Second is a reversible constant entropy process called as a reversible adiabatic process, where work is done by the system at the expense of internal energy and the temperature is increased. The third process is a constant temperature process, in which heat leaves the system and the internal energy of the system further decreases. The final process is a reversible constant entropy process, in which work is done on the system and the internal energy of the system is increased and restored to point 1, and the temperature rises from T2 to T1. Next comes the Rankine cycle. There are 4 processes in the Rankine cycle. 2 of them are isobaric, that is constant pressure, and 2 of them are isentropic, that is constant entropy. First, the working fluid is pumped at constant entropy from low to high pressure at constant temperature. Second, the high pressure liquid enters a boiler where it is heated at constant pressure by an external heat source to become a dry saturated vapor. Third, the dry saturated vapor expands through a turbine generating power. This decreases the temperature and pressure of the vapor. Fourth, the wet vapor then enters a condenser where it is condensed at a constant pressure to become a saturated liquid. Hence, we first saw what the Carnot cycle is and then saw what the Rankine cycle is.
I hope this video might have given more clarity about what is a Carnot engine and what is a Carnot cycle and what is a Rankine cycle and how both are differ from each other. Next, let us see detailed comparison between Rankine cycle and Carnot cycle further. Between the same temperature limit, Rankine cycle provides higher specific work output than the Carnot cycle. Consequently, the Rankine cycle requires a smaller steam flow rate, resulting in smaller size plant for a given power output. However, the Rankine cycle calls for higher rates of heat transfer in boiler and condenser. Next difference is, since in Rankine cycle only part of the heat is supplied isothermally at constant higher temperature T1, therefore its efficiency is lower than that of Carnot cycle. The efficiency of the Rankine cycle will approach that of the Carnot cycle more neatly or nearly if the superheat temperature rise is reduced. And the final most important comparison between these two, based on the advantage of using the pump to the feed liquid to the boiler instead of compressing the wet vapor, it obvious that the work of compression is very large compared to the pump, so that the amount of work required to start or required to push the engine or the system in Carnot cycle is much more compared to the Rankine cycle, since the amount of work supplied is less. The difference between these two will give more less, and efficiency will be more, because the heat supplied comes in the denominator part of the formula. Since denominator decreasing, the overall efficiency will increase more. Because of that, Rankine cycle efficiency is comparatively more or better than the Carnot cycle efficiency. That's it guys for this video's discussion, and we will meet in the next video. Till then, bye bye and take care.